this version, planning and implementing a successful lake dredging project, really was, I made a lot of updates for this year's ILMA conference because they agreed to let me speak for an hour instead of the usual half hour. So I was able to pack more information, just looking at the various photos. The center picture is from Paris, Illinois. It was a water supply lake. It was a hugely successful project, and the location of the sediment storage and dewatering facility was absolutely ideal. So everything turned out great. There's a couple of examples of different dredges. Go ahead to the next slide. Trying to breeze through some of the and minimize some of the narrative and text. A lot of this information I have to put qualifiers is not only from lessons learned from involvement in actual projects, but constantly researching any and every situation that could possibly come up. All the way down to the smallest dredging project, and everyone needs specific attention. Next slide. Sometimes it's easy to tell that dredging is needed. You might see a delta forming in the upper right photo. Low water levels might expose all kinds of sediment that you might not have been aware of other than your boat propeller hitting it. Or you might see very brown turbid water being agitated by your boat propeller, or an island maybe forming at a creek mouth. Next slide. Those are just obvious. And so I felt like it was important to create somewhat of a basic flow chart. Hey, we think our lake needs dredging. What do we do now? And you would go through a couple of choices, which you can do. Let's do a survey so we know what's there. Where are the problem areas? What's the sediment like? If we dredge, where do we put it? How much will it cost? Which is the best method? Mechanical, hydraulic, which are predictable, removal methods, versus I will talk a little bit about, you know, shall we say, bio-augmentation options on a couple of slides later, but that's not my main focus. Usually it's for, navigation impacts, loss of water depth, which is critical. So, but what regulatory permits will be required? And that's going to be based on what method of dredging you choose. If you hydraulically dredge, you need to approach it a certain way as far as permits go. Next slide. And then so it's very important to gather the right information to make these planning decisions. It's very expensive. We want to do it right. Let's make sure we've got the information. What areas are impaired, in terms of access, water quality, etc. How much sediment has accumulated? What are the physical and chemical characteristics? We need to sample the cores and analyze them. How many cubic yards? How do we remove it? What method is best? What size, what type of equipment really is most suitable? And then that really, there's so many options out there as far as equipment and methods. Where can we put it? How much is it going to cost? How do we pay? All these questions. And in a lot of cases, although I'm not a professional engineer, I'm a geologist, I always had a professional engineer on staff, because certain permits require a PE stamp. And lately, in the last 5 years, I've been more focused on helping a local engineer with a PE to execute the project by giving them proper design and permitting guidance and how they should approach it. And it's worked out quite well. Um, Considerations, once we determine these dredging limits and quantities, and a placement site is secured, and you'll never catch me using the word disposal, other than right now to qualify. We have to have plan drawings to clearly show a contractor what we want, or a regulatory permitting agency what we propose, and how we're going to, comply with regulations, environmental regulations. Bid specifications are hugely important to not only, spell out clearly what the contractor is supposed to do, how it's going to be measured, how it's going to be paid for, you know, uh, to eliminate problems during the project as much as possible. A post-red survey is critical once you do the pre-dredge survey and you dredge, oftentimes very important to do this always, because it's underwater. Even though the dredger thinks they've dredged there, they may not have reached the levels that were proposed. So in order to get the quality job with the results you want, you got to verify it. Next slide. Next. Yep. And permitting requirements in Illinois are
You want me to go
last
back?
slide. You
Oops.
just went by permitting. So, and rather than reading through every one, there's a process of going through the local, Corps of Engineers regional office, but copies would always go to Illinois EPA and Illinois DNR, and it's the Corps who determines, whether a permit is needed, for instance, and what type. And if it's a hydraulic dredging project, there would be effluent water returning, and right away you need a specific EPA permit. If you need to store the sediment in an earthen impoundment, it could be a permitted dam. An Illinois DNR dam permit may be required. If you need for instance, an NPDES permit because you're disturbing more than 1 acre of ground, upland ground to put the sediment, here's another case where a PE, professional engineer, is required. And like I mentioned, although I'm not actively bidding projects and doing the construction monitoring by helping various engineering firms, some of which are located in northeastern Illinois, et cetera, Wisconsin. It's been very helpful for them to avoid pitfalls that they're not familiar with. So that's been a good thing. It's limited how much time I have to spend, and it helps to make a successful project. But in many cases, a professional engineer is needed, and many of which are not necessarily very savvy with dredging. So certain firms are, and much more are getting familiar. Go on, next permit. Oh, start early because the regulatory process can really be time consuming and take longer than you would hope. And some of
Mhm.
the benefits, you could get increased water depths and storage capacity that's lost to sediment deposition. You can improve and expand your recreational opportunities, safe boating and navigational access. You can also expand and improve your aquatic habitat conditions for fish and other aquatic life. Improved water clarity and quality can occur also from reduced internal sediment and nutrient recycling from physical resuspension, which pulses phosphorus back into the water column. It's like if you had an extreme storm event, like we've had many of this spring, at least down here we have, and up north, that can really agitate the bottom sediment and resuspend and remobilize phosphorus. So dredging can really help to reduce that. Water supply reservoirs, it can be critical to increase the storage volume, to prevent shortages during a drought, for instance. And it's been proven by a really great study done at Delavan Lake in Wisconsin, which I've done work with them for almost 20 years now. They've found that there are increased property values in local and regional economic benefits, et cetera, as a result of a properly implemented project. Go on, next slide. A sedimentation survey is absolutely critical. And beyond just getting a hydrographic or bathymetric survey, which only tells you what the water depths are, it's critical to not only know how deep the water is, but how thick the bottom sediment is. Because, for instance, as you see, this is just an example. I like to try and the more transects, the better, the more points that you measure depth, the better. The more closely those point intervals are, the greater the accuracy. But the bottom line is if you need to assess the lake, you know, going across the lake in a series of strategically located lines or transects can show you that, well, at this location, it's, you know, 8.8 feet, and the hard bottom underneath the soft sediment is 10.6 feet. Well, if you had 2 feet of sediment and you were in a very shallow portion of the lake, which was only, say, 1 or 2 feet deep, that 2 feet of sediment has a much greater impact on your access and your water quality conditions. So it's very important to know not only how deep the water is, but how thick the sediment is. If you have 3 feet of sediment and you're looking at the bottom of this slide and it's 8.8 feet deep, it's not really a critical impact like it would be, say areas of Butler Lake are very, very shallow around the littoral zone or, the area closest to the shoreline. Whereas it may only be 1 feet deep, and the sediment could be 2 or 3 feet deep, very organically enriched. That's a huge impact, and it sets the priority of where you want to dredge and how much. And that's why the survey is so important. Next slide. Another version that another company has done, and I really like, where you can view it and you can see different contour lines which show existing water depth down to the top of the sediment. And then they may show different colors and numbers to show the thickness of the sediment, for instance. Like if you see in this example, there's an area that's orange and has lots of sediment. It may have been a deeper hole, for instance, sediment collected in. But overall, it gives you an idea of how the sediment is distributed. If I'm in water shallower than 8 feet, for instance, then I start to take a closer look. And if I see that there is 2 or 3 feet of sediment widespread in an area that's less than 5 feet deep, that sends, flags up. And then I focus on these are your priority areas where we should attend to, most prominently. So that's why these sediment surveys are so important. Next slide.
Sorry, just
Um, Same one. Let's see. There you go. And there's different measuring tools. I've always found, a pole that you could push that had markings you could push down through the sediment. I love having a pole that has a disc at the end because it gives you a much more accurate measurement. Oftentimes in lakes, and I'll just throw out there, such as Butler Lake, which has a very, very loose, organically enriched sediment, a simple pole with no disc at the end, like in the top left photo, makes it very difficult to get an accurate measurement because you can't feel the sediment in the upper 6 inches, for instance, until you get some gradual resistance. There's other methods. Obviously you've got to use a GPS system. Boats who do this regularly, could be using a calibrated sonar unit that's telling them depth, but it's ultra critical, in my opinion, to calibrate those measurements by pushing a pole down through the soft sediment. Is areas in Lake County where there's peat at the bottom and a pole may not hit a hard bottom. And then you have to decide, what's best for that situation, like targeting a maximum dredging cut depth, for instance. But you use GPS, whether it's handheld in a boat or running lines back and forth, that can easily give you water depth or bathymetry. Dual frequency fathometers have made claims. I've tried to use them and had very, very mixed results. It's very important, I think, to take at least some measurements using a pole that has measurements that when you push it down, you feel a hard bottom, you record that measurement, and you then can know how deep it is and how much sediment is there. The easy way out using this dual frequency method has not panned out, in my opinion. It's very inaccurate. I really think you've got to measure, and in most cases, you're not having to do this in water greater than 10 feet deep because it's not really as much of a problem, worth, getting stressed out over. Next slide.
mhm. Sorry.
Next. So a cross section, back up. This is just a one slide. These are typical lake sections. And when you measure these points going across the lake back and forth, you can target a transect and you create this profile view, this cross-sectional view. And it's extremely important because not only can it allow easy calculation of volumes, but it visually can show the non-scientist lake person how the sediment might be impacting them. If you're looking at this bottom section, for instance, the hard bottom is just barely 6 feet deep, and there's 2 to 3 feet of sediment. So the existing water depth in this case is only 2 or 3 feet deep. So that 2 or 3 feet of sediment in relation to the top, which is 9 feet deep, is not maybe quite as great. And dredging is expensive per cubic yard. That's why it's ultra critical to know this. Where should I prioritize my dredging areas, depths, and limits? So the cross section to me is like a must. It's like the Bible of dredging. Go on. Next slide.
Oops. Sorry, there's a slight delay here.
Yeah,
There.
these are
Okay.
basic slides. I can talk about them if anyone asks. Core samples, sediment samples, I think are extremely important, not just because Illinois EPA will likely require some if they are cognizant enough to read your permit. They're not known to be very quick, but they do have specific requirements. And a core sampler, that you push down into the sediment, it allows the sediment to be put into a tube, which you can see my right hand holding in the upper left-hand side. You can immediately cap it, put it in a cooler, ready to be sent to the lab. If you're hydraulic dredging, you would also be getting gallons of lake water because you have to mix it at a certain ratio and analyze it according to, certain procedures. But as you can see, there's different types of sediment. The upper right-hand column was from Third Lake, and that was primarily an algae biomass that was so thick from top to bottom, as much as 3 to 4 feet, very, very watery, 95% water, and it was hydraulically dredged, versus the slide below it was from Wonder Lake, where there was a lot of this gravel and cobble present, which can be a
Mm.
real problem for the dredging, depending on the method. The middle one, leaves may be a huge problem. Sediment may be super fine grained, which will cause the sediment to settle more slowly. So it's very important to understand not just the chemical characteristics, like is it high in lead, for instance, or are there pesticides or PCBs, for instance? In most cases, no, but the physical characterization, in my opinion, is extremely critical in terms of meeting your permit requirements, knowing how to approach it, and designing, your dredging methods and storage methods, storage and dewatering facility, configurations. Next slide. Generally, I don't get to say this much about sediment, but it's extremely important in the planning process. This was actually pretty rapid. The time span, if you mix sediment and water up, as EPA requires a 1 part sediment to 4 parts lake water to simulate hydraulic dredging and discharge into a dewatering facility, not necessarily geotextile tubes, and then you measure the amount of time it takes to have most of the solids settle out. And if it doesn't settle out almost completely after 24 hours, you're probably going to have to use some type of a flocculant to make the particles suspended settle out more quickly. So this is another, you know, part of the dredging Bible of permitting and design. Next slide. Obviously, if it's all sand, it's going to settle very quickly, and that makes life easier. But typically, it's not. It's usually organically enriched with leaves and plant detritus or silt and very fine-grained particles. So settling doesn't occur quickly. Um, up in Lake County, space is at a premium. There's very little open space, to store and dewater sediment in an open earthen impoundment, for instance. Although I've had many up there that have worked out quite well. one of which, Third Lake, was on Forest Preserve property, which has since been graded back over and, shall we say, turned back into ecologically important habitat. So you've got to, if you have a large enough project, you may have to try and identify and secure an adequate upland storage location, a parcel of land that, optimally would allow water to drain back to the lake, so that you're not just draining the lake and letting the water flow away somewhere else. It's best to have the water be able to return to the lake just by gravity flow. And
Mhm.
sometimes you have to, create a map like this and investigate what possibilities are there before we go even and talk to the landowner about could we, lease this land for 3 years, or could it be purchased, or, et cetera. In this particular case, the big rectangle in the upper right-hand side, the landowner agreed to, you know, allow them to use the land and restore it later. So
Mhm.
how far is it? How high is it? Is there a wetland on site? Does water drain back? All these criteria go into selecting the proper site to store all of your dredged material. Next slide. This is if it's a larger project and more complex, and you're trying to really evaluate, each potential site, how far it is, how high it is. The further it is and the higher it is, like Wonder Lake in McHenry County, there were at least two booster pumps used on that project. And we had to, in order to pump sediment from the furthest location and up 95 feet higher than the lake, it was up to 3 miles. So, you can get extreme. It was a pretty good sized project. It was 500,000 cubic yards total. There are pictures within here that show that from an aerial view, but it's just an example. This type of matrix can help in the planning. Like, for a smaller project, probably not so critical. You're probably going to be really lucky to be able to get a large enough piece of land to store the sediment on, and you may be forced into using geotextile tubes possibly, which can, use a smaller space. Or one project I had in Delavan, Wisconsin, there was literally no space, and we had the back of a fire station with what's called mechanical dewatering, using belt presses and centrifuges. So you're actively creating soil that could be hauled away on a daily basis. And that's a more expensive process. But when you don't have any land, like in Lake County, for instance, it's highly populated, and you know, open land is not readily available all the time. Next slide.
Mhm.
Um, this is actually a picture of where the yellow arrow has an arrow pointing to it, the yellow dotted line. That was the sediment dewatering facility, which in Illinois EPA's eyes, they they consider that to be an industrial waste treatment facility, and they permit it as such. That's where a PE, as professional engineer, is required because it's that type of permit. So you can see that distance, the lake dredging areas went all the way to the north and all the way to the south. Well, that pond that you see with the yellow arrow pointing to it was about 45 acres in size, but it's also 95 feet higher than the lake. So you've got to pump that sediment and water slurry all the way up and cross different obstacles like a road or a culvert. It had to go by various things to get there. And then the water would then, in the blue, drain back to the lake. And that is what has to be sampled, and it has to be compliant with Illinois EPA regulations. 15 milligrams per liter of total suspended solids is what's required. Uh, and you can cross railroad tracks. You might have to cross roads.
Mm.
At Butler Lake, that was the case. We had to cross through a railroad underpass, um, bike paths, etc. So you have to deal with this and look at the distance, and that distance and elevation that you're pumping to will also dictate what type of dredge and how many booster pumps might be required versus something that, say, a really good local firm uses, a very small dredge that might be pumping hundreds of feet into a geotextile tube for a very small project. That's a different consideration. You could only pump so far, and so 10 feet high and 1,000 feet high, maybe, or far, but anything further, it would be limiting for that, like say a 6-inch dredge, a Dino 6, or even a truck saw, very low, small cubic yards, hundreds of cubic yards, maybe very small. This was 500,000. So you
Mhm.
could use a
Wow.
larger dredge, and you needed that larger dredge to get it all that distance and all up that high. Next slide. Obstacles just to show that there might be an existing culvert. The county is probably going to get worked up about you occupying some of their stormwater conveyance space. You have to go back and forth with different entities and groups. You might come across this is actually lower left photo is the graveyard that was adjacent to the Butler Lake dewatering facility before it got all graded back
Oh,
over. The county health department was built there.
oh,
But you might have to run the pipe across, along a bike path or other feature. And there's different, next slide, go ahead. You just have to consider all these things. And as an engineer, that they're typically used to that, but they must be aware of it. I mean, in a way, I was also heavily targeting this PowerPoint. If an engineer that had never worked on a dredging project before was to try and undertake it, it would give them some more insight into how to avoid screwing up on the first project. Um, but there's different methodologies and sizes. There might be hydraulic dredging using a larger rotating cutter head for much bigger projects like Wonder Lake, for instance. If for a smaller project that you're just dredging soft silt, you could use a horizontal auger dredge. It's like a snow blower, snow thrower that's working underwater. That could be lower turbidity, very small projects. There could even be a diver operated unit, but some of the horizontal auger dredges can be very small, like a 4-inch diameter hose used for the truck saw dredge is going to maybe give you 10 or 15 cubic yards an hour dredging. This is very
mhm.
small work, small projects. Whereas a 6-inch dredge might, pump 1,500 feet and pump 25 to 40 cubic yards an hour. So depending on how big your project is, you've got to size the dredge accordingly and appropriately. There might be mechanical excavation from a barge while the lake is full, which in most cases is. If you had a situation that you could dewater the lake and use dry dredging, but that's very risky. I've
Mhm.
fortunately done some, but you can get slammed pretty heavily. The contractor can if you get a 4-inch rain while you get the lake drawn down, or if you have
Wow.
the lake drawn down and it's fall and you don't get any rain, you might not fill your lake up very quickly. If there's a drought, for instance. So bio
This
dredging is another option with, in my opinion, aeration, oxygenation assistance. Um, I'm going to comment on it briefly. Water injection dredging is,
and
is a
Peter,
development.
just a quick
What?
time check. You have so many rich slides, and I did distribute them to everyone.
Yep.
And if
Should I
we want
go,
to
should I go
allow time
faster?
for,
Or?
we have a lot of questions in
So,
the
so as
chat.
you can see,
So
there's a lot of dredging and
yeah.
dewatering options. Look at them. I try to explain each. Go ahead on the next slide. Different types of hydraulic dredges with
Mhm.
rotating basket type cutter heads. Next slide. There's auger dredges, horizontal. There are swinging ladder dredges for long, narrow canals, channels, etc. Next, next slide. Oh, that last slide, go back real quick. That was at Third Lake, and that's where the
Oh,
algae biomass was.
this one?
Aphanothece pallida was the species. Next slide. Jim Bland probably remembers it really well. His house was right in the midst of it. So this is hydraulic dredging with conventional dewatering facilities. Lower right was the Munder Lake project I mentioned. Um, the upper left was Lake Springfield and upper right, and you can show how the large dredge swings back and forth as it cuts, and the dewatering impoundment in the background. Next slide.
Mhm.
See if we can go through this. The sediment dewatering facility should be designed to store the targeted dredging volume plus additional space for freeboard sediment bulking and settling while dredging. Next slide. That's an example of another SD. That's actually in Lake County for the Fox Waterway Agency. And they periodically clean out
Oh,
the cells and haul the material over and they screen it and they've been able to sell it as topsoil for about
mhm.
$200 a truckload. So periodically this is cleaned out so they can reuse it and refill it. Next slide.
Oh,
Very
sorry.
important if you're going to have to continue doing it periodically. Um, Hydraulic dredge mobilization is a huge endeavor. It's a big dredge. It needs a large crane to deploy it. You got a fused pipeline, thousands and thousands of feet. You can see the crane dropping the dredge in. You know, that may be needed for a larger dredge, larger project. Smaller projects, you can launch them off of trailers. Next slide. Hydraulic dredge discharges and water control structures. You can see how it's dark and thick. Upper left, Wonder Lake. It's got a nice rich thickness of sediment mixed with water. It's a slurry. It's typically about 15% solids, the rest is water. So you use these water control structures to raise and lower the water levels to retain the water so it settles properly and you can maintain, space and operate efficiently. Next slide. The effluent water you can see on the lower right has to return to the lake somehow, and you may have to control that water so it's not eroding the channel that it's, dropping into. And the lower right, you can see how it's clear, versus mixed with sediment. You're trying to achieve a clear effluent. And if it's clear, you might be in compliance, but you take samples to confirm whether it is or not, and you send them to Illinois EPA every month. Next slide.
Yeah.
Polymers or flocculants might be needed in the upper left. You can inject it into the pipeline. It mixes. And by the time it discharges into the dewatering facility, you can get fairly clear water as shown in the lower right. But it may be needed because if you don't achieve EPA effluent compliance, you're probably going to have to stop the project or face a fine. So you got to do what's needed. Geotextile tubes can be an effective option for dewatering and storage. You can have several layers. You pump into the tubes, clear water comes out. A polymer or flocculant is needed. But essentially, there could be, you know, a contained volume of dredged sediment that later you can then break open the tubes and haul away nice, solid, rich soil. Next slide. Here's another example of geotextile tubes. You may have to have a series of inlet pipes so you can selectively pump into tubes. You have to have nice clear water coming out, but your sample would be taken from the lower right, for instance, after you have, shall we say, matched the appropriate polymer. You're getting gin clear water. You take this sample, you send it in, you hope you're in compliance. But essentially, the permit says you got to meet these conditions. Mechanical dewatering is what I mentioned. If you don't have the space to even lay out enough geotextile tubes, never mind build a dewatering pond. Here's a series of clarifiers and belt presses and even coarse material separators because there's all kinds of branches and plants and stuff that you need to take out. So essentially, you're building up in the center, you can see a nice soil stockpile. And every day during this project, trucks would come and fill up with this nice soil, which is shrunk in volume by 40%. So
Wow.
you're hauling a lot less. a lot
Mhm.
less volume, and hauling costs money. As you can see, it goes from wet sediment down to nice, rich, stockpiled soil for this
Mhm.
process. That at the time that was, you know, fairly expensive, but hey, it got the job done. These are just some of the components for coarse material. Sand is taken out with the hydrocyclone, and that's where you have sediment that has different grain sizes and material. Next slide. This is just more examples of the mechanical dewatering system. Ultimately, Wisconsin DNR, this was Delavan, Wisconsin. Gin clear water is a good sign. They were happy to see that. Great
Mhm.
project. Here's more soil and soil being put into trucks and hauled to a nearby, facility that the landowner allowed use. Next slide. Dewatered sediment at the placement site. You're getting, you know, various hydric soil species growing. I mean, there's like, bulrushes, embedded into the seed bed. It quickly, this is within a week, it was growing.
Wow.
Wet mechanical dredging from a barge, scoops the sediment, puts it into a hopper barge, offloads it at shore, and dumps it onto a flat site, hopefully surrounded by a perimeter berm, and it dumps out into like 20-foot diameter cow pies that you then was Illinois DNR then graded that material to a nice even thickness and planted sunflowers, and they grew like crazy. So it's a lot for hunting, and wildlife feed. Uh,
Mhm.
Turbidity curtains are
Oops.
typically required around the dredging area to contain any resuspended turbidity. This is
Mhm.
mechanical dredging with long reach excavators. This was a golf course lagoon that was dewatered. Um, it, it's very risky. As you can see, 4 feet of sediment. If you get a big rain, you can lose your
Mhm.
equipment and it can settle into, I mean, it's very risky. And you have to
Wow.
have it well thought out and be able to bypass stormwater runoff very easily. Next slide. Biological dredging is using beneficial bacteria and microbes, and it's often targeted, with aeration technology to hopefully biologically digest and break down organic sediment and muck. And read through these. I think that there are more potential uses for this in highly organically enriched. It does not break down inorganic material. It presumably can function more effectively on organic sediment. And in organically enriched lakes, where you might have 20% organic content, that means that you potentially could, you know, reduce sediment thickness by a number of inches, for instance, because if, you'll do the math, go to the next slide. It's not going to make sand or silt go away inorganically. Um, but different researchers have had much different results. Um, Typically, from what I've observed, using appropriate laminar flow aeration, in conjunction with the bacteria and enzymes works the best. But if you have a lake with low organic content, like most Illinois lakes do, Butler Lake is pretty high in organic content. So where you might gain potentially 6 inches through either self-consolidation or material transformation, 6 inches of a gain in a shallow plant-enriched littoral zone, like a Butler Lake, for instance, could
Mhm.
be a relative great improvement if it's only
Mhm.
2 feet deep. You follow me? So, but
Mhm.
if you've got sediment with only 6 to 10% organic content, that inorganic portion is most of the sediment. You're going to be limited potentially by, well, actually, by what you could. Now, self-consolidation, I think, is probably occurring, and I think that needs to be studied more. But if you can gain anywhere from 2 to 4 to 8 inches of depth, and it could be meaningful in a very shallow area. That's where I see, a greater potential. Water injection dredging is still not allowed in Illinois, but I think it has its place. Read the slide later. I don't want to spend much time. Next slide. Beneficial use of dredged sediment, there are many, and it's not something that should be considered spoil. Most cases are not contaminated with harmful materials, and they could be used for many things. But at a very minimum, screening might be required to get some of the debris out of it to make it more desirable soil. But there's many options for doing that, and all take effort. Next slide. I know I'm trying to go fast, but so
You're there.
basically a strategically planned and properly implemented lake dredging project can provide many long-term benefits, especially when soil erosion is controlled in the surrounding watershed. Any
Mhm.
questions? There you go. So I know we're probably not a lot of time for questions, but I'll do what I can, and anything that comes after that, send emails and I always will answer.
Yeah, well, I'm going to put your email in the chat, but I know
Okay.
Paul has already. Well, maybe before we go, Jim, could you just comment since that was right in your backyard? Nice to have you
Oh,
here. I
is
know
Jim Bland on this?
Jim Bland is
Oh my
on the
word.
call.
Hello.
Yes,
Yes.
and you're muted right now, so I'll come back to
Oh,
you, Jim, if you wanted to comment. But Paul had a bunch of questions. If you
yeah.
could just shoot, I know so many of them were answered in some of the content, so I'll let you speak, Paul.
Let's go.
Yeah.
Sure,
Questions?
great. So regarding the benefit of removing internal load phosphorus, is it critical to dredge to the hard bottom so that the result isn't just exposing a new layer of phosphorus-laden sediment?
Well, there's many, many factors that go into that answer. And dredging alone, especially if it's in deep enough water where it is going anoxic and it's accelerating the rate of phosphorus release from the bottom, dredging is not necessarily your answer there to try and remediate. If you're in shallower areas, you should try to get as much, down to the hard bottom as possible, because in shallow areas, you can have, agitated sediment and phosphorus release from boat propellers, especially from if you're allowing bladder boats and shall we say, wakeboarding. It can have a really deep impact where those pulses can resuspend and remobilize bottom sediment that's also rich in phosphorus. And if you're shallow enough, typically less than 6 or 8 feet deep, even strong sustained wind, say over a longer fetch distance, can remobilize that sediment. But if you're in deep enough water, in my opinion, okay, and many others, but if you're in deep enough water where you are thermally stratifying and you are going anoxic, it's greater than 15 feet deep, for instance, 18 feet deep, and you're down in an area which is going anoxic and you're releasing phosphorus at a particular rate, going after it with a deeper dredging effort is not really the answer I would be looking for. I would feel that that's not subject to physical, agitation and remobilization, and it might be better to approach it from either an aeration standpoint or even an alum treatment standpoint, where you're locking that phosphorus into that bottom sediment, which presents a whole list of other questions, some of which Jim Bland could talk about for a long time. It's fairly complicated, but you have to understand all of those criteria before coming up with the right solution. So dredging just to eliminate phosphorus is more targeted for shallow areas where it can be physically agitated by runoff velocities or wind or boats or heavens, wakeboarding. I'm sure it's a blast, but you can agitate sediment up to 8 or 10 feet deep with those things. Next,
So
let's
I,
go.
I have two more questions, but if I put them in the chat, should I
Oh,
hit those first
uh,
or just rotate among people that have questions, Mary.
Yeah, why don't you just go, and if I think you had the majority of questions there. I will check others. Mary had a question too. We wanted Jim's comment. So go ahead, Paul.
Okay, so do
Please.
dredge spoils that are not removed from the watershed?
Oils,
Dredge,
sediment,
oh,
dredged sediment, recovered topsoil.
dredge sediment. Oh, there's no
Who knows
spoils.
who you're talking to
Dredge
here?
sediment. Dredge sediment that's not removed from the watershed
Yes,
eventually leach phosphorus back into the lake via either groundwater or surface runoff.
it can if it's not stabilized. The
Mhm.
more stabilized your soil is, especially in the fragile springtime, the more people who are using cover crops, perennial buffers, perennial crops, the more vegetative cover, the more no-till alone is not enough. No-till alone still leaves soil exposed to when you get a sudden 3-inch rain in 2 hours, you're going to agitate that sediment and get a pulse of phosphorus like crazy going to the lake. So the less exposed the soil is in the watershed. Very difficult to get that across to all agricultural producers. But the more exposed soil you have, tilling is obviously the worst, but having cover crops, appropriate perennial buffers, perennial cover, the more you've got that protected and stabilized, the less phosphorus and soil will erode and come back to the lake.
So my final question,
Yep.
do aquatic plants need to be killed with chemicals prior to starting hydraulic dredging?
Not necessarily. And I really don't like, my personal opinion is I try to avoid herbicide treatments if at all possible, because all it does is kill the plant, it lets it die, decompose, and then remobilize as future phosphorus. So dredging, if you know that you're going to potentially encounter plant growth at that time of season, the right dredge, can handle it, but it may have to be considered as part of the dredge bid price because it may occupy volume that may not be measured as sediment. Like a small, tiny dredge may have difficulty cutting through plant material. You may, if you know that that's going to be an issue, you may want to target the timing of the project accordingly. You know, early spring before Memorial Day, for instance, as much as possible. You follow me? Down here in central Illinois, we're dying to get some plant growth. It's too turbid typically for plants to grow. So yeah, you've got to consider that and the type of dredge that would be used.
Mhm.
Any more?
Excellent. Yeah, we do have another one from Mary, but I'm not seeing it right now. Mary, if you could unmute, and Clyde has raised his hand. So, Clyde, go ahead.
Well, Mary, you've got the question. You got one question. I have another one, but you raised it first, Mary. So you go and then I'll go. How about that?
Oh, okay,
Um,
good. So my question is that given the expense of dredging, we're considering dredging for navigation purposes in a phased approach. And I was wondering if there are any best practices for phased dredging. And then, with limited funds, what is the best way to make progress, knowing that partial dredging is maybe less than ideal?
That's a great question. And number one, it's very important to collect this type of data right away when you're doing the sediment survey. Okay. If you're doing a sediment survey, you're also trying to understand, at least I am trying to understand, and others should, how dense the sediment is. Number one, supposing you're in like a narrow navigational channel or area,
Mhm.
and you're hoping that that you can limit how many cubic yards are dredged, but still giving you good access. So if you're cutting a channel, for instance, an access navigational lane, you want to know what the density of the sediment is like. It's called either based on the water content. I go by feel. There's a measurement, you know, called dry unit weight or dry bulk density. In other words, the softer the sediment is and the higher the water content, the more likely it will be to physically flow back into the channel after you dredge it. You follow me? Which is
Yeah.
then you cry. So, but if the sediment is denser, and what is denser, the lower the water content, the higher the solids, the
Yeah.
denser the sediment, the more difficult it is to push a pole through it. It's 1 inch in diameter.
Mhm.
Versus what I showed you at Third Lake was so high in water content that a pole would just slide right through it. You follow me? But a tern bird could walk on the top of it. But if it's dense and you're cutting this navigational access lane, for instance, and it's denser, it may have a more of a propensity to stay in place. You follow me? So it's a range of flowable to more stable. And if it's such as that and it's flowable, you may approach it as a benched type of approach. Like you're really watching how many cubic yards you want to dredge and where you're going to put it because it's cost money. So you want to be as thoughtful in your approach as possible. And if an engineer is not familiar with this type of thing, at least the client can learn what questions to ask. You follow me? Because if you
Yeah.
cut, there was a lake, and I won't name in Wisconsin, that was trying to propose dredging 25-foot wide channels or 50-foot wide channels, which would fill back up in no time. Sediment from the surrounding area would just slough back into the channel. So the wider the channel, the better. The denser the sediment, and that's a whole nother discussion I could talk about for 15 minutes. The denser the sediment, the more likely it will be to stay in place versus sloughing back into the channel that you just spent money dredging. Does that help? Any more?
Does. Thank you.
Great question, Mayor. Yeah. And then Clyde, and there was a question on this being recorded. It is and will be on our Lake County Lake Lover Third Thursday playlist on YouTube, which I put in the chat there. So, and I'm just thrilled. I know we're at the time at the top of the hour, and I just want to say, Peter, how grateful we are that you addressed this presentation and added information on our biological dredging and came so prepared. So it was just really wonderful. And if anyone needs to leave, they may do so now, but we'll remain on for just a few more minutes. So,
Sure, I'll hang out for a few more minutes. There's a couple more burning questions, or
awesome.
you want more? I
I
mean, it's a
I
topic
have
of love, so it's okay.
I have one comment. I'm glad that
It
Peter
is,
is
there he
still
is.
I'm glad that Peter is still using polling. I think that I'm glad to see that, and I think that for the other people that are watching that, we're hopeful, Peter, that you don't own all of that dredging equipment personally. And in terms of the organization of your company, the presumption is that you do technical oversight over these dredging projects, but you work with dredgers and leasing of equipment. So if you could explain how your company operates just a little bit, that's
Well, my,
fine.
my company is just me,
And pass
and my
that.
company is slowly, shall we say, fading off into the sunset. So, but in most cases, and I probably should count them up, but I've helped at least 60 or more projects through to completion. And in most cases, it has been a design, bid, build, where you design the project, you plan it, you do the permitting, and you accept, you try to present a clear set of guidelines or plans, drawings that show a contractor what they want to be doing, what they need to be doing. And typically bids are solicited because in 95% of the time, it even every organization wants to get more than one bid typically. So as far as doing a project in-house and leasing equipment, it's very difficult to find success going that route. In some cases there has been, In most cases, most projects I've worked on that have been successful, you're working with a contractor who has been, they can't even submit a bid unless they can show they're qualified.
Mhm.
And typically the lowest bidder may not be the one selected if they're not qualified. You don't want to just, I never allow a bidder that can't show real project experience relevant to even participate. So the
Mhm.
specifications are critical. If you're going to try and do it yourself, you've got a whole list of other considerations that I probably could do another PowerPoint on. But it's risky. You typically fail, especially cities. Cities have a real rough time because of unions and getting enough trained, skilled labor. A lake association has a chance. But in most cases, lake associations, I've worked with many that have tried dredging themselves, and they've not done very well. Um, I don't know, hope that helps a little, but going out and leasing equipment, if you're a novice, it's very risky. Good chance you're going
Wow.
to fail.
Yeah. Heavy duty equipment. So Jim, thank you for chiming in. And Peter, so glad
Good to
that you
see you,
don't own
Jim.
all of
Yes.
that. Yeah. And Clyde had a question.
Thanks, Mary. Appreciate it.
Yeah.
Peter, thanks so much for the comments and very informative on the technical side. I think I'm going to build on both Mary Spiewak's comment and your last comment about unfortunately those efforts that have failed. And my question really is, what advice would you have for associations that are using private money when the work that needs to get done is far in excess of the money that's available? And we've seen many times that over decades that efforts have started and then fizzled out. So what are for the 60 projects that move forward, what advice do you have on how to actually get something done? Um, I know all the steps that have to get done without, just, the volunteers,
But
stopping or the money not being enough.
well, the money is a problem, because there's no grant money for dredging. You can maybe
Understood.
get some grant cost sharing for doing watershed work or, other enhancements, water quality protection enhancements, et cetera. But dredging grant money is non-existent. I mean, a great example is what Wonder Lake did. They basically set up a special service area, situation where it was tied to like location and property values to allow very low interest repayment over time. And that allowed, in that case, they had, quite a number of property owners, which helped lower the overall cost per property owner per year spread out over time because it was tied to annual property taxes, which made it a little bit more palatable and also had a very, very low interest payback. But for a small private lake association, annual dues aren't often enough. Many, have to dredge every 7 or 8 or 10 years. It's a matter of trying to plan and put money aside, whether there's, other fees besides HOA fees that could be used. But that's why it's so important to be pinpoint on what you're going to
Mhm.
dredge and where.
Mhm.
I mean, targeting impacted areas in less than 8 feet of water or even 6 feet of water can help minimize how many cubic yards you need to dredge. Because if you're in 8 feet and 10 feet water, what's your problem? You're not really needing to go dredge all those extra cubic yards, which, even in the larger projects, you're spending 10, 12, $15 a cubic yard. It adds up quickly. So budgeting,
Is
annual planning ahead, annually trying to add to this fund. A lake I helped out in western Iowa, had some nonprofit organizations really pulling for them. They were able to do a lot of fundraising. You might have to explore a number of fundraising opportunities, but I can't hide the fact that it is costly.
No, and appreciate that. And I think we agree with you that it's got to be very targeted and you're just going to have to draw some boundaries to start and
And the
get some stuff
methodology
done.
is very important.
Yeah,
You know,
agree.
um,
Thank you.
what's the best way to achieve your goal? And that's why
Yeah.
even when I set up like I said, recently I work with other engineers and have instructed them who a bidders list would be. And once you decide what's the best approach for your lake and your volume and your distances, etc., how to match that equipment need with the right contractors. Because different contractors have different types of equipment and are more suited to, you know, small projects versus large projects, excavating versus pumping. And it's a matter of knowing, I've kind of lost touch with a lot of them, unfortunately, but it's a matter of knowing what equipment is best and how to approach it that way.
Thank you.
Anything
Yeah.
else?
I don't see any other questions in the chat. Throw up your hand
No.
or comment or just open your mic if you do have a question.
Yep.
Peter, you have given us a wealth of information in a very short amount of time, and the pictures, all the experience that you contributed to our group is going to be reused in our Third Thursday playlist.
Well,
And
I do like the idea of sharing it. And if you view those slides and you're scratching your head, like, I'd really like you to say more about that,
yeah,
send me an email.
and you are also in the community. I saw you joined, so thank you for that. And we will post it. I'll send you a link to that posting so you can also comment and see questions there. But I am just delighted to welcome everyone to a long weekend and welcome you all to the Lake Lover community, which the Lake County Lake Lover Group is actually forming its own nonprofit. They've grown so rapidly. They're about 500 members, but we included a number of links, and you can find us. If you haven't joined the community, you can just Google Lake County Lake Lovers and or else join here. I did have just one question, one idea that might be useful to everyone else. St. Mary's has created a silt barrier under a bridge, and they now dredge just this platform by the bridge regularly because it builds up all the silt that would have come in
Yes.
from Loch Lomond. It's a very clever way to do that pinpoint dredging, it seems. Are you familiar and are you seeing
Well, it's just a specific, approach to a sediment trap.
Mm,
And in that
mhm.
particular case, whoever saw it and identified it and modified it, it appears to be functional. I haven't seen it myself. I'd love to sometime, but a sediment trap like that can protect the lake and isolate a buildup of material that can be then easily excavated later and reused. And it's not always that simple in other lakes that have big tributaries coming in and much more massive amounts of water flow and sediment flowing in, nutrient loading.
Yeah.
So in all cases, I believe keeping it in place is most important. Perennial cover crops, no-till plus cover crops, et cetera, buffers, but keeping it in place is the most cost effective. And then preventing it from getting to the lake also helps, but it's not always achievable.
Hmm.
I can think of many instances, but all those things should be looked at. It's a holistic solution, typically,
Yes.
in my opinion,
And
of course.
yes. And as Peter ventures off, he's going to his own lake property now, and which he has created to apply all of these skills on his personal residence. What's your first
Well,
priority?
I'll help them as much as I can. Right
You're a
now, I'm trying to
helper.
figure out how to get a boat so I can go out and enjoy it. Right? Um,
Oh,
anyway, if there's any more, um, go
yes,
for
let's
it. If
just give him
not,
a round of applause as
thanks for
Becky
coming.
does. Yes, we really appreciate you and um, thank you. I see you kept everyone on for the duration, and we just look forward to sharing more of this and seeing everyone at the July 19th, the Lake event, the Lake Appreciation event. Because of summer, we're going to take June off for our third Thursdays right now.
Ah,
So,
how about
um,
that?
yes. So enjoy your summer, you guys, and we'll see you out
Take
lake
care. Yes.
monitoring too.
Pleasure all.
Okay. Yes. Have a great weekend.
Thank
Okay.
you.
Thank
Yep.
you all.
Thank
Thanks.
you.
Bye bye now.